In this video, I will show you the CAN bus interface, which is part of the Opal development kit. The Opal CPU module includes two CAN bus channels, courtesy of the Freescale i.MX53 processor. On the development kit, we provide a physical interface to these channels using microchip CAN transceivers and push wire connectors. This connector takes 18 to 24 AWG solid and stranded wire. Once you have stripped off the insulation, it is easy to push the wire into the connector. To release the wire, we have included a tool with the kit. Push this into the hole just above the wire and pull out the wire. The Opal development kit also has digital inputs and outputs using the same connectors. Let's do a quick demo. To keep things simple, we have done a physical loopback between the two CAN ports. A transmit application sends out the status of user button 1, and a receive application sets user LED 1 based on this status. The demo uses Windows embedded Compact 7 and the CAN driver implemented by our OS partner GuruCE. The code is in C++, but GuruCE also have C# wrappers, enabling you to access the driver using the .NET Compact framework. Let's take a look at the transmit application code. The first thing we do is initialize the CAN driver and set the bitrate. Next, we do some GPIO setup for the buttons. We cover how to use the GPIO in another video. The main part of the application has the transmit code, and this sends 10 messages every second. To send a message, we use a CAN frame structure and set several fields, including the button status and the message data field. The message is then sent with the FlexCAN write frame function. Switching to the receive application, we see that it has the same setup code for the CAN and GPIO drivers. It also creates a thread to process the messages received. This application uses the standard CAN driver, but there is a more sophisticated high-performance driver that makes use of the FIFO, filters, and other features in the silicon. This is recommended for applications that need to process a lot of messages. In the receive thread, we call FlexCAN read frame, which returns when a message is received. We then set the LED value based on the data in the message. This has been a brief introduction to the CAN bus features on Opal. For more information, visit devicesolutions.net/Opal.